Today I'm going to present my work on governance protocols, where I will present a measurement analysis paper that I wrote, and it's currently under submission. When we talk about decentralized governance, we have these smart contracts that defines how to amend or update or change applications on the blockchain. This is paramount, right? This is so important because these contracts from time to time, they need to be changed. But then the question is, how can we change it then? And how can we perhaps propose changes to these contracts, right? So typically they define a set of rules on how we can change these contracts, typically through voting, through a proposal. We're going to talk about this in a sec. And the voting power here, typically, the voting power is the decision-making power that each individual has, each stakeholder has in the system, is essentially one token, one vote, which means that one participant who has 1 million votes will have 1 million votes, kind of. Or you can see a vote with a weight of 1 million, just for simplicity. We have two main mechanisms. So for instance, we have on-chain voting and off-chain voting. We're going to discuss this in the next slide. On-chain voting basically implies the users paying a fee to vote, because by on-chain, these users, when they want to propose or want to vote on some proposal, they need to issue a transaction, and then these will require to pay a fee. For instance, imagine on Ethereum, when we have high gas prices, right? And then we also have some terminologies here about token ownership. It basically means that who owns the token, who possesses the tokens. This person or this user can exchange, can do whatever he or she wants with these tokens, right? And then there is token delegation. Many protocols nowadays, governance protocols, they allow people to do some kind of liquid democracy, which means that, let's say I don't want to vote, therefore I can delegate my voting power to another participant. So that participant can, even having no tokens at all, but he or she will have at least my voting power. And I can, at least for Compound and Uniswap, it's all or nothing. I delegate all my tokens to that individual, or zero. There is no way I can split using just one wallet. Of course, if you send these tokens to many wallets, then theoretically speaking, you can delegate to many participants, right? Who can vote? So typically, voting is made by people who have delegated tokens to themselves. Even the token holder can delegate the tokens to themselves, which means that in order to vote, you have to have delegated tokens. Otherwise, you cannot vote, even if you process the tokens, right? And then, as I said, there is on-chain and off-chains, each of them with their specificities. For instance, on-chain votes ensures transparency and immutability. You see everything on-chain, the voting cast, everything. And off-chain voting might be faster, right? Because you don't need to issue a transaction on chain, but again, you lose some stuff, mostly regarding transparency as well. And perhaps, depending on how it's implemented, even security. And we also have some mechanism for voting. For instance, voting, so traditionally speaking, it's a majority voting style, but there are some protocols that can also apply some quadratic voting weights, which means that one token is no longer one vote. In a linear progression, but in the case of a quadratic voting style, if you want to have a vote size a weight of 2, you are gonna need to have double of the tokens, let's say 4 in this case. So it's quadratic, right? There are some protocols that requires you to lock in the tokens. And then let's say if you want to participate in our decentralized voting, you need to lock your tokens for some amount and of time, and depends on the amount of tokens you lock it and the amount of times, let's say 6 months, 1 year, you're gonna have less or more voting power in the end. There are others that introduces and uses some continuous voting, which means that as long as it's locked, your votings count, but as soon as you withdraw, then you lose this your voting supporting some proposal, kind of this way. There are some other proposals as well. For instance, mostly of the protocols I analyzed here, they used a fixed quorum, which means that the minimum amount of in favor votes each proposal has to have in order to be able to pass. So it's majority vote, but then you have to have at least a minimum amount of votes. Typically, in Compound, it ranges around 4% of the total supply, which means that even if your proposal has a majority vote, but doesn't have the minimal votes in favor, as known as quorum, then it's going to be rejected. There are some proposals, for instance, the nouns DAO, which is discussing about dynamic quorum, which is essentially means that for each negative vote the proposal receive, it would need way more votes in favor to reach the quorum. So because the minimum amount of in favor votes is increasing of depends on the votes against that proposal. Yeah, and then they have a bunch of interesting discussions there. I can share some links if you are interested to know more about it. So because of all these features, functionalities, there are many DAOs nowadays. In this paper, I focus mainly on Uniswap and Compound, but in this talk, I'm gonna primarily focus on Compound. But for further in detail analysis, feel free to check my paper. There will be a section discussing Uniswap there with all these things that I'm gonna show here and discuss about Compound for Uniswap as well. Then in my paper, I explore these research questions. For instance, okay, people can vote, but how frequently do these people vote? Are they voting pretty often? How does that work? Because if you have a DAO in place and people are not voting or not using their voting power, so why would you want this thing, right? And this can also trigger some problems regarding the distribution of tokens as well. So if you have a participant with most or the majority of the tokens, so this can be unfairly to other users, right? And then it's like we want to investigate that. And this has also serious implication towards the decentralization of DAOs, right? So we want to measure how small or large is the set of voters who actually determine, have a say in the outcome of the proposals, as well as what is their actual voting power, right? Third research question is regarding how cost it can be for voters to exercise their voting power. So as we are talking about Compound, then it's an on-chain voting. At least during my analysis, I'm going to discuss the data set pretty soon. I gather data from Ethereum, mainnet, and then voting can be really expensive, right? Because of transaction fees. And final research question that I'm investigating here is, okay, so let's analyze how each voters cast their vote in favor or against or abstain. Do they form coalitions? Do they have some similarity in terms of how they vote? Let's think about that. Assuming that the voting distribution is really fair, but if voters are colluding or voting in terms of forming coalition, then again you have a centralized problem here. So the contribution of this paper, it's basically 5 topics here. We characterize governance protocols, and we do find that there are proposals being proposed from time to time. We're going to discuss these. Most of the proposals receive majority of the support. We also analyze the token concentration, where we show that just a few participants in Compound, when we look at all the proposals that passed, only a few participants would be enough to reach the quorum as well as to pass the proposal. So this may seem strange for small players. We also analyze the voting cost, whether this can be expensive or cheap. How does actually cost to cast a vote when we look at the past of the compound proposals? As I said, voting pattern of the delegates or the voters. So do they form coalitions? And one thing that I really advocate for in every paper I write is regarding scientific reproducibility. So as soon as this paper gets published, I mean, not on archive, but of course in a scientific venue, then my goal and my plan is to make all my data set as well as all my codes fully available on a GitHub repository, linking to some other data repository, so that anyone will be able to reproduce any analysis I did in the paper. This is something that really I really advocate for. And as I said, this paper, although talks about Compound and Uniswap mainly, we are gonna focus on Compound. But then, as I said, this is a measurement analysis paper. We need data, right? How can we get this data? So in order to do that, I deployed the Ethereum archive node, which is running in the Max Planck Institute server. And I built a bunch of code that basically helps me gathering this data from the Ethereum archive node, that pre-process, and I extract a bunch of events related to Compound and Uniswap. And this data is basically up to November 2022. Of course, maybe it's worth updating this data set and redo the analysis to see how the new patterns and the data, whether our finds still hold, right? So you know that we have transparency, but at the same time, the public wallet addresses there might belong, let's say one user might have many wallet addresses, right? And these can be complicated in our analysis. For instance, when we want to analyze who the voters are, right? At least the top voters, as they can create many wallet addresses they wish, then we had to get some labels. So I crawled all the labels from Etherscan, from cbu.org, as CBU list as well, which is a website provided by Uniswap that allows people to disclose their identities, I mean, match their wallet addresses with their Twitter profile. To do that, you have to sign a message, post on Twitter, and then you verify that your Twitter username actually matches your wallet address. And they have these things there. Typically, the top voters, they prefer to disclose their identities. And then I also got some data from the Compound forums and try to match the users' identities with their wallet addresses. That's how I inferred some wallets or address ownership, and then I could aggregate, let's say, a top voter who had 2 wallet addresses. I could aggregate them together. Regarding the data I got mainly 2 types of data. I got regarding the Compound token, which gives me the number of approval events as well as the attributes related to that. When the delegated change, delegate votes change, and transfers. Transfers is essentially I send some tokens to someone, right? This will be useful for me to compute the account balances over time. And regarding the voting, I got events from the Compound Governor events, which is essentially regarding canceled proposals, proposals created, which gives me the title, the descriptions, what people are proposing, when this proposal was created, when it passed, when, yeah, all this kind of stuff. The proposals that were executed in our dataset is 101. Proposals queued, and vote cast as well. In total, there were 9,500 votes in total for 133 proposals. So, talking about Compound, right? This is a decentralized lending platform, right? It uses the Compound Governor Bravo for their decentralized governance. And one interesting thing here is that many DAO protocols they are essentially a fork of the Governor Bravo, including Uniswap. So these might have some serious implications as well in terms of security, but I don't explore these in my paper, but I briefly mentioned something about the security aspects of DAOs. Imagine if there is a bug here, and then it will necessarily imply that all the protocols who forked Governor Bravo from Compound would need to also release a update. Whether they know about this issue or not, then it's up to each protocol to basically keep a track of these bugs, right? Typically, proposals last for 7 days, but what happens in practice is that typically when a user wants to propose anything, they first post on a forum where the community can discuss about this proposal, even this proposal being officially proposed on chain. This is kind of a temperature check whether this proposal makes sense, and people can comment on that for get more feedback or even do some adjustment even prior proposing officially. And each proposal here, as you can see, there are summary, there are a bunch of stuff, even sometimes plots describing some simulations, whatever. And this is traditionally the pipeline of a proposal lifecycle. Actually, once it's proposed on chain, you create the proposal. It has 2 days for people to review this proposal, so they can cancel. The proposer can cancel this proposal if they identify some issue there. Right after 2 days, this proposal, the voting period starts. It lasts for 3 days, typically for Compound and Uniswap, maybe for other protocols as well. And as soon as the 3 days ends, then you have the outcome, whether the proposal passed or if it was defeated, right? Once it's passed, it will be queued in one step we call time lock, which lasts for 2 days, which is the time for implementation, even for the discussion. And keep in mind that prior the execution of a proposal, I mean, when the proposal actually is said to be part of the protocol, prior to that moment, the proposer can cancel this proposal at the end time, prior its execution. Once it's executed, then you have to roll this pipeline again, and then to propose a fix or something like that, which happened in the past. But again, the community is pretty vigilant in terms of analyzing which proposal is being proposed. Then, based on my analysis, I saw that at least in Compound, every week we have at least one proposal. Here I show, for instance, the number of proposals per time, per date. So we have a bunch. There were some days we had 10 proposals, 10 to 11 proposals around March and May 2022. And we have some symbols here that shows green circle whether the proposal was executed, defeated in the red X, or in the diamond blue, canceled. So it happened that proposals are also canceled. So when we look at the proposal's outcome, we saw that, as you can see, proposals are canceled at the end time, even during the time lock. And on Compound, during the analyzed period of 133 proposals, 101 were executed, while 17 canceled and 15 defeated. So as you can see, most of the proposals, they passed, right? And this may be the case that just because users, even before proposing them, they engage in discussions, and they will be engaged in discussion even throughout the reviewing process, voting period, and so on and so forth. And when we look at the support each proposal received, here we have the 133 proposals, which there is how voters vote for those proposals in percentage. So as we can see in the green circles, most of the proposals, they passed, right, as the right figure is showing us, but the left one shows that most of them passed with votes in favor of that proposal, which is on average 89% of the votes are essentially votes in favor, which is really a high amount of support, right? And then when we look at the distribution of the tokens, I mean, who owns those tokens? Who has actually tokens delegated and how much? So here we have, let me just load all these plots here. So we have in Compound 10 million tokens, which is the total supply. These were, at least during my analysis, distributed to around 210K users, accounts actually. Where 7.3 million of these tokens were in circulation, while 2.7 million were locked by 3 accounts, let's say Treasure, and so on and so forth. So the total tokens you can see in the left plot, where top 15 accounts holds actually 56% of all the 10 million tokens. And in the plot in the middle, we see the distribution of holders considering only the tokens in circulation, which what actually matters in the end, right? And the plot in the right show us the tokens delegated distribution. Let's say it's essentially the amount of tokens the participants delegated to other accounts. This translates to voting power. Who has a voice in the system? So the top 15 accounts to around 63% of the total voting power, which basically informs us that the voting power is highly concentrated among a few participants in the system. And when we analyze the amount of participants or voters that need for a proposal to pass, based on our analysis, we found that on average, it was around 3 voters to obtain at least 50% of the votes, which is really, really worrisome. For instance, it shows how, at least in this case, Compound and of course Uniswap, which is in the paper, are the delegated tokens are highly concentrated among a few participants. And this has a serious implications for the decentralization of this voting power. Who has a say in the system? So is this actually decentralized? Who knows, right? It doesn't seem so. And regarding the percentage of the votes in comparison to the total available voting power, on average, we saw that the voting turnout is 33%, which means that among all the delegated votes available, only 33% of them were being used to vote. So the remaining, they were not being used, to be honest. And in the beginning here, basically we see a plot that shows the participation percentage, where you see also whether the proposal was executed, defeated, or canceled. We see that in the beginning of Compound, the voting turnout, the voting participation was higher, but again, by that time we probably didn't have many participants, right? But nowadays it's quite low, and it ranges around, at least during my analysis, around 20% of voting participation. And voting cost can be really expensive for some participants. For instance, here I show the distribution of voting cost per proposal. This is essentially a box plot showing the median and the total cost per proposal as well in US dollars at the time when the proposal, when the vote was cast. So yeah, so this is the voting cost in US dollars at that time. So it also takes into consideration the gas price fluctuation as well. So based on this plot, we see that voting can be highly expensive. So voting in a proposal can range from 3 cents of dollars to almost $300. The average vote here, when we look at the past 133 Compound proposals, were around almost $8. But one user can have more than one token, which means that when we normalize this voting power per delegated token these accounts have, which I call here cost per vote unit or voting token unit, the on average can reach easily 350, almost 360 US dollars. So these can be really expensive for small players in the system, favoring only big players on voting. And then when we look at the patterns, so for instance, how do they actually vote? Do they form coalitions? We use some similarity measures here. So the figure on the top, you see how each of the top voters voted on each of those proposals, where green is in favor, blue abstained, and red against. And the figure in the bottom basically shows us the heat map of the similarity. So basically, it measures how similar are those people or users actually voting. So we see that the top players, they tend to vote almost similarly, which means that one top player votes in favor of a proposal, the others also tend to follow. But in this paper, we didn't analyze who follows what, because this may be really an interesting analysis to do. For instance, do small players wait for others to the big players to cast a vote and then they cast theirs? Because it tells us that perhaps this may be the case, or even the voting turnout or voting participation is quite low, because basically me as a small player, why would I care voting if only 3 top voters would be enough to pass a proposal? Why should I care? So my voice doesn't count in the end, right? So perhaps this may be something interesting that I could explore as an extension of that paper. But then the conclusion here is essentially users they actually participate in voting with some caveats, right? So users actively vote on proposals. Typically, almost 89% of the votes cast are in favor of a proposal. Voting cost varies significantly. For instance, it can be a few cents to a few hundred of dollars. And this can be disadvantageous or unfair to small players in the system. And when we normalize the voting cost per unit, then it's way worse. And the voting power, as we see during the presentation, is highly concentrated, where 10 voters hold around 50–80% of the voting power. And in Uniswap, it is for almost 45%. It's in the paper. And on average, on a compound, only almost 3 voters would be enough to reach the quorum and pass those past proposals. And we see that voters, mainly the most powerful voters, they form coalitions. By that, I mean they vote similarly. And then one thing that we can think about is, yeah, there are a lot of problems. Yeah, but I mean, how can we actually improve DAOs, right? As a researcher, usually when I think about improvements or anything, first, I prefer thinking about the research questions. So, and then that's how I start doing anything in my work. So, for instance, I have some of them here that can be used to expand this paper, as well as to write another paper describing these things. For instance, which metric can actually accurately measure the decentralization of DAOs? It's basically the Nakamoto coefficients, which basically measures the amount of, the minimum amount of users that has at least 50 or even 51, depends on your metric, percent of the voting power in this system. Actually, also, how can we perhaps provide incentives for people to vote? Because, so far they are spending money to cast a vote, right? This may be the case that justifies why the voting participation in Compound is quite low. Maybe in roll-ups, it's a different story, because the voting would be way cheaper. And as we have a centralized sequencer, we can also refund the fees to users, right? Eliminating this problem, or even relying on some off-chain voting mechanism, right? But then if we provide incentives, the natural question is, can users game the system to get more rewards in the end? And can we stop some natural equilibria here in such a way that we ensure that there is no way they can game this system, because if they have a chance, they will eventually, right? And second, I mean, third, how can DAOs actually achieve privacy for the participants while maintaining some form of transparency? So traditionally, voting in real world, essentially, I mean, when I cast a vote, even if I want to prove to someone that I vote in favor or against some candidate, I cannot. There is no way I can prove that, right? And then why should we have this in DAO? So probably we should have some kind of transparency here, while I cannot prove to who I vote, but I can prove that I vote or something like that. Perhaps we could think about or brainstorm about some situations here. Uh, then how can DAOs actually leverage emerging technologies? So for instance, imagine in a hyperchain or layer 3. So if the tokens are deployed on one chain, how can I account for those when, I mean, across chain or even on hyper layers or multi-chain as well, right? This is one thing. What might be the better way in terms of scalability and security? Because if the voting participation is too low, this we may have a problem here, which means that it will be easier for participants holding, let's say, maybe some amount of tokens to try to propose something that benefits themselves. And this happened in the past, for instance, where some protocols basically bought a bunch of tokens and then they proposed something to vote, and then they could essentially sell these tokens after they got what they want, right, implemented. And then how can we avoid voting by buying intimidations and coercion? This is really an interesting question. And perhaps the third topic we mentioned on DAOs achieving privacy may be a solution here, because I mean, if I want something to pass, I can basically pay someone off chain, and then they can use their voting or basically delegate to me, to my address, and then it's like I can pay them a fee, whatever. And then it's like, how can we mitigate these things? Perhaps this is more related to the privacy while maintaining some form of transparency that we should be really careful think about. Then how can we rigorously analyze and verify governance models? So is there any way that we can know that the proposal that passed was actually implemented in the way that it was described? So is there any way that someone can introduce some kind of code there that was not actually discussed or part of that proposal? Then how can we design user-friendly interface? So the motto on blockchains is not for tech people, right? It's to bring everyone in the available. It's like you can vote, you can use, right? Because otherwise, what is the point of blockchains in the end, right? If normal people cannot use, right? It should be more ubiquitous in terms of people utilization, right? Then how can we perhaps have better visualization, dashboards, whatever, better softwares that actually makes it easier for them to understand, as well as to cast a vote and to understand what actually is happening underneath, right? Or at least in a high level idea. Like AI nowadays, people use it, maybe they don't know how it works, but they have a clear idea. They know that it's on their phone, it's on their car, and on the plane, everywhere. So probably we should invest more on that. I mean, the research community at least. And then finally, how can we automate testing experimentation? So how can we ensure, automatically speaking, right, that this contract actually is implemented according to the proposal description, which is related to how can we verify those models, right? But in an automatic way, because maybe if we, based on humans, maybe different humans can have different decisions in the end. So yeah, so that's all I have for today. I really thank you so much for attending this talk, and feel free actually to reach out to me to discuss about governance or drops, anything. And with that, thank you so much.